Good morning, everybody. Today we're going to start applying what we know about proportions to some different situations. The first thing we're going to look at today and tomorrow is something that comes up in geometry with similar and congruent polygons. Now, similar and congruent may be words you've heard before, maybe they're not. Same with polygons. We're going to make sure we understand what these words mean first, and then we're going to get into how we can use what we know about proportions to figure things out about polygons. So we're going to start with defining polygons. So a polygon is a closed figure with three or more sides. Okay, we got some examples. Okay, here's a triangle. Okay, here's a quadrilateral. Here's a pentagon. Okay, these are different examples of polygons. Notice we have straight lines for sides. They're all closed, which means we don't have like something left open. Like, let me show you what that would look like. It's not something like that, right? Where there's like an opening. Right, they're all closed shapes. They end up where they started. And it has three or more sides. It has to have three or more sides because you can't really draw an enclosed figure with two sides, right? If you start with one side and you want to draw your second side, you got to end up back here, and it's got to be a straight line. So you just go right back to it, and you have a line, right? That's not really an enclosed figure. So it has to have at least three sides, okay, and be a triangle. So that's what a polygon is. Okay. Corresponding parts. Let's talk about corresponding parts. So when we have two polygons, here I have two pentagons. They're the same shape, but they're different sizes. Okay, whenever you have two shapes like this, the corresponding parts are the ones that if you were to like make them the same size and overlap them, they're the ones that would line up. So they're kind of in the same location on the figure, right? So these are both kind of oriented the same way, and this upper left side is shaded here. This upper left side is shaded here. Okay, it's important to note though that we might take this shape and like twist it and like rotate it around so it's not sitting this way. These would still be corresponding parts, right? So you got to kind of line things up kind of in your head visually a little bit to see if they were facing the same way, what would match up with what. Okay, we'll get some practice with that as we go along. All right, so congruent. Let's define congruent. Congruent polygons. Two polygons are congruent if their corresponding sides and angles are the same. Okay, so we got couple of triangles here. Here's a good example where they're not really facing the same way. Okay, if you think about taking this and rotating it so that this is on the bottom, that's what you need to do to overlap with this. So this side would line up with this side would line up with this side, and the short side will line up with that short side. You notice I got these little tick marks that kind of tell you what lines up with what, right? So the line with one tick mark lines up with this one. Two lines up with two, three lines up with three. Okay, and then you can see kind of what the corresponding angles would be too. So like this angle here is between sides 2 and 3, so it would line up with this angle. Okay, if we twist it, it would overlap with this one. So these angles correspond. Okay, these angles correspond, and so do these. Okay, so if those corresponding angles are the same measurement, you have the same shape. Okay, so they're the same. If the sides are the same size, they're also going to be the same size. Okay, so the angles are what determine the shape. If you think about changing these angles, it would change the shape of these triangles. Okay, if you change the length of the sides, you'd make it bigger or smaller. Okay, but if these are the same size and same shape, we call that congruent. Okay, you can think of it as being identical. All right, so the way we write congruent is by using this symbol. Okay, it's like an equal sign with a little kind of wavy line over it. Okay, the way we would read a sentence like this is saying triangle AFH. Okay, so that means the triangles that have the points A, F, and H is congruent to triangle QRN. That's just triangle with the points Q, R, and N. Okay, now you might be able to kind of tell how we would need to rotate this to match up with this. If you think about turning this one kind of on its side so that the Q matches up with A, the R matches up with the F, and the N matches up with the H. Okay, that's kind of how it's positioned. Personally, I'm not a very visual person, so that's kind of hard for me to do. So fortunately, we got a clue kind of embedded in how we write the statement. Okay, so something that's true about a statement like this is the triangles are going to be named using things that match up in the same order. Okay, so if A is first here and Q is first here, that means A and Q correspond. Okay, F is in the middle, R is in the middle, that means F and R correspond. And H and N are both at the end, so they correspond. Okay, so that's another way you can kind of figure out what lines up with what if you can't kind of picture it turning. Okay, so A is going to match up with Q, so Q is going to go there. F is going to match up with R, and H matches up with N, like we said. Okay, so if they're congruent, we know that all those corresponding parts are the same. So if I wanted to find, for instance, Rn is the way we're naming one of the sides that goes from R to N. Okay? If I want to find the length of this side, okay, if I think about it rotating, it's going to line up with this side. Okay, so if this is 9 inches, that means this one is also 9 inches. Okay, so again, you can picture rotating it if you're a visual person. Otherwise, I see RN are the last 2 letters here. I know it's written the same way, so it's going to line up with FH. Okay, FH is right here, it's 9 inches. Okay, if I want to find side QR, okay, well, QR, that's the first 2 letters. I know that's going to correspond to AF, okay, right here, okay, which you can kind of picture again if you rotate it. So if this is 13 inches, this is also 13 inches. Okay, so we can find some of the sides that way. We can also find some of the angles. Okay, so if I want to know angle N, for instance, okay, let me write down the answers we found so far. So this is 9 inches. This is 13 inches. If I want to find angle N, I know angle N is going to match up with angle H. Okay, so if we rotate it, this is going to line up with this. That means they're going to be the same measurement. Okay, this is 65 degrees, so that means this one is also 65 degrees. Okay, last question we're asking here is angle R. Okay, so I know angle R is going to match up with angle F if we rotate it, but angle F is not labeled. So in order to answer this question, we know R is going to be the same as F, but we got to figure out what F is. Okay, so to answer this question, we got to know something about triangles. Okay, specifically, we need to know that all of the angles inside of a triangle add up to 180 degrees. Okay, so this one's 40, this one is 65. This number has to be something so that they all 3 add up to 180. Okay, so if I add 40 plus 65 together, I get 105. So to figure out what that last angle is, I have to take 180 degrees, okay, which is the sum of all 3, and subtract 105. So that's what those 2 add up to. If I do that, I get 75. So I know this is 75 degrees, which means R is also 75 degrees. Okay, so if they're congruent, you can just see what parts match up, and then they're going to be the same. Okay, let's talk about similar. Similar polygons are polygons that have the same shape, so their angles are all the same. So remember, the shape is defined by the angles. And it has corresponding sides that are not equal, but that are proportional. So this is where some of the stuff about proportions that we've learned is going to come into play. Okay, so proportional, if we use that proportional reasoning again, that means, like, if we look at corresponding sides, okay, let's say this side is twice as big as this side. Okay, if that's the case, that means all the sides here are going to be twice as big as the corresponding sides. Okay, so we can use proportions to check to see if things are similar and to find out missing sides if we have them. And that's exactly what we're going to do. Okay, so in both congruent and similar polygons, they're going to be the same shape. Okay, that means all the angles will be the same. Okay, but the difference between congruent and similar, congruent are also going to be the same size. Similar is not going to be the same size, but it's going to be a proportional size. Okay, so let's look at some examples of that. So if I want to see if these two things are similar, I'm first going to check to make sure they're the same shape. Okay, so I look at all the angles. Okay, make sure the angles are the same. Okay, all these have the little box in the corner, which means they're all right angles. Okay, so all the angles are the same. I can guarantee that. Okay? But I also have to make sure the sides are proportional. So looking at these rectangles, we see we only have two of the sides labeled. But that's okay because it's a rectangle. I know that these are going to be the same size and these are going to be the same size. So I just have the short side and the long side, short side and the long side. Now I started off with kind of a tricky one because these aren't really oriented the same way, are they? This has the bigger side on the bottom. This has the smaller side on the bottom. So we got to kind of think about taking this shape and turning it so that they're oriented the same way. Okay. But in terms of corresponding sides, the small side here has got to correspond to the small side here. The big side has to correspond to the big side. Okay. So I'm going to write a ratio, and I'm going to write a proportion, and I'm going to check to see if it's true. Okay, so comparing the small sides, I got 15 to 25. Okay, that's this to this, equals 18 to 30. Now, you heard me say before, there's a lot of different ways to write proportions, and that's especially true in cases like this. There's a lot of different ways I could write this, but we need to be consistent. And we need to be consistent in a couple of different ways. First, we need to be consistent in that here I'm comparing the small side of the small figure to the small side of the big figure. So this is small to big. This also has to be small to big. Okay, so in both cases I have the smaller side on the top, bigger side on the bottom. Okay, I have the smaller shape on the top, the bigger shape on the bottom. Okay, and so it's consistent in terms of small shorter side to shorter side, bigger side to bigger side. But because I started off with the 15 on top here, I got to use the same shape for the top here. Right, so I couldn't do 30 to 18 here. If I have the 15 on top in the first ratio, then I got to go back to the same shape for the top number in the second ratio. Okay, and that might have been a little confusing, but we'll do more of those, and I think that'll make sense. All right, so there's a couple of different ways to check to see if these are the same. We could reduce them and see if they reduce to the same thing, or we can multiply. Let's go ahead and multiply these out. Remember, if the cross products are the same, that means the proportion is true. 15 times 30 is 450. 18 times 25, if we punch that in, we also get 450. Remember, you can be using calculators on this to show me what you're putting in the calculator. Okay, so the fact that they both multiply to the same thing means that they are proportional. All right, why don't you try this one on your own? So determine if we're assuming they're the same shape, but check the sides, see if the sides are proportional to see if they're similar. Okay, when you're ready to go, click resume. All right, welcome back. Hopefully you got the answer that no, they are not similar. If I check to see if these are proportional, okay, I look, this 8 is the longer side of the triangle, okay, and that's going to correspond to the 12, right? So 8 and 12 form a ratio, okay? So I do a ratio of 8 to 12, okay? Then if I look at the other sides, I started with the 8 on top. That means I got to start with this shape on top in the second ratio as well. Okay, so 8 to 12, I come back to the small, 6 to 8. Okay, so big to small, big to small. Okay, so 8 to 12 equals 6 to 8. If I check to see if that's true, I multiply, I get 72 there, 64 there. So that is not proportional. You might have also noticed this reduces to 3/4 and this reduces to 2/3. So that's another way again to check to see that they are not proportional. Okay. All right. Let's do another one. Okay, so this is our rectangle. All the angles are the same. Okay, short side is 10, big side is 14. Your short side is 5, big side is 15, sorry. So I'm going to write a proportion. The 10 corresponds to the 15, because those are the short sides. Okay, then because I started with 10 on top, I go start out with the 14 on top here. And the 14 corresponds to the 21. That's the longer side of the rectangle. Okay. All right, so this time I'm going to reduce. 10 and 15, I know they're both divisible by 5. So those reduce to 2/3. 14 and 21, I know are both multiples of 7. So if I divide by 7, I also get 2/3. Okay. So those that is a true proportion, which means yes, these figures are similar. Okay. Let's maybe have you do one more if there's time. All right. Try. Let's not do one more. Let's go on to some quadrilaterals. All right, so here I have a case where I have two quadrilaterals that are similar. You notice I got these weird kind of arcs in the corners. What those mean is that these are the same measurement. So A and W, they have the single arc. Those match up. B and X match up. D and Z match up, and C and Y match up. Okay. So in this case, it tells me to find M. So I'm given two similar figures. Okay, we're assuming that we were told these are similar, and I have a missing value here. So what I want to do is I want to use proportions to figure out what M would be, because I know the sides are proportional. So I'm going to start out writing a proportion using what I'm trying to find out, which is M, and what it corresponds to. Right? So M corresponds to 12. Okay, so the ratio between this shape and this shape is M to 12. Okay. Now for the other shape, I want to find any other pair of sides that correspond. So I know 24, but I don't know what it corresponds to, so I can't use that one. This is 13, but I don't know this one. However, I do know that these two, DC and ZY, these also correspond. Okay, so I can use 10 and 15. Now be careful how I use them. Remember, I start out with the M on top, so I'm going big shape to small shape. Means I got to start with the 15 on top here. So 15 to the 10 that corresponds to. Okay, and here I can use what I've been doing with proportions and solve to get M. So I do 10 times M is 10M equals 12 times 15, which is 180. Do my train tracks. Divide by 10 to get M by itself. And I get M equals 18. Okay. So I can use proportions, what I've been doing with proportion solving, to find missing shapes based on the fact that those are similar. Okay. I'm going to have you do one. We've just figured out that M is 18. I'm going to have you see if you can figure out what side AB is. So we'll call this X. So figure out, well, I'm using X for a side. Let's do N. Okay, so let's figure out, pause it here, and see if you can figure out what N is using that same process. All right, welcome back. Hopefully you got N equals 16 for your answer. Okay, N equals 16. Okay, so setting that up, we're trying to find this, and N corresponds to this side here, 24. So that should be my first ratio, N to 24. Okay. From there, we had a choice. We still can't use the 13 because we don't know what corresponds to it. But we could use the 10 and 15 again, which is what I did. Or we could use the 12 and the 18 now that we know that this side is 18. Okay. You should get the same answer no matter which one you picked. I chose the 10 and 15 just because they're a little easier numbers. Okay, but I did N to 24, so I'm doing the small shape to the big shape. That means for these, I need to do the same thing, small shape to big shape, 10 to 15. If you go ahead and solve the proportion, you should get N equals 16. All right, so that's all I got for you. Go ahead and give this some practice. We'll talk a little bit more about this tomorrow. Good luck.